So we're going to look at second order differential equations. And the second order differential equations are generally of the form a d2y dx squared plus d plus b dy dx plus cy is equal to f of x. And to solve, we need two parts. Number one, we need something called a complementary function, right? And number two, we need a particular solution. So whenever we're solving this, we have two parts, okay? A complementary and a particular solution, right? When you combine them, it will look like this. The general solution is complementary function plus the particular integral. Right, copy that down. Ready? So to get this real easy, if you remember what I tried to show you last day, in order for us to get the complementary part of the solution, complementary function, all we have to do is make f of x equal to 0 and solve a quadratic. That's it. Right? Once you solve the quadratic, you're going to get three options: two roots, a one root, or complex roots. Right? And then you choose the right one and you have complementary function. The tedious, not difficult, the tedious part is getting the particular entry. All right. So here, next heading, obtaining the complementary function. Ready? So if f of x is equal to 0 in equation 1, we have the, so if f of x is 0, we have the homogeneous equation a d2y dx squared plus d dy dx plus cy is 0. Right? All we did is I made f of x equal to 0. Right? Which can be written right? Which could be written as this: au squared plus bu plus c is equal to 0, known as the auxiliary equation. We actually are not worried about it, and I'm also saying security. I think this is what I'm trying to take it. Right, sorry. So what we have here, when you make f of x equal to 0, we have this is called a homogeneous equation. And we can easily turn this into auxiliary of that original equation. Right? You recognize this is out? Quadrant. Okay? So I want to give you the general solutions now for that. Anybody right there? Right, so all this long thing here is basically saying, take the equation I gave you, make it equal to 0 and turn it into a quadrant. That's all. Right? That's all this long thing saying here. Copy that. I just want to give you this solution, right? Ready? I'll write on this side here, right? Right? Here's what it's saying here shown. If you were to solve this and then end up with two real roots, one being alpha, one being theta, then your complementary function is a plus e, whatever alpha is, plus b plus e, whatever beta is. That's it. That's all you have to do. Yeah, can't you? So take the auxiliary, solve it. If you get two real roots, that's a complementary function. Right? If you get equal roots, it will look like this. If you get equal roots, it will look like this. Y is equal to e to the alpha x. Remember, you'll only get one root, right? By a plus bx. These are just constants, right? A and b are just constants. Right? What's this here? if we end up getting complex roots, something like this, alpha, you remember complex with I in it, right? If you end up getting complex roots looking like this, alpha plus or minus beta I, then the general solution looks like this. Take your alpha, put it here, take your beta, put it here. This is capital B all here. This is capital B here. Right? This is beta. All right, I want to show you how to use this now. So all you're doing, convert it into auxiliary equation, solve. If your answer is 2 roots, that's your solution. If your answer is equal roots, that's a solution. If your answer is complex, that's a solution. Real easy, right? All you have to do is remember these solutions. Okay? Copy them, I'll give you one. Let's try one. Huh? Good now. Anybody else want that? That's good one, but chicken. Yes, bring it there. Thanks. Huh? Can I have chicken on my that's why hello? Oh, I can't remember. Timer. You get to put on your phone and timer. All right. Go ahead. Yeah, so it's not shrimp but chicken, right? What I do? Huh? I take no chance. I take no chance. Huh? Nah, don't break out already. Come something. Right, ready? So let's say I gave you something like this, right? Instead of writing d2y dx squared, I wrote it like this, right? So suppose I gave you this homogeneous equation here. I already make it equal to 0, right? Then the auxiliary, right? The auxiliary will be u squared minus 8u plus 17 is equal to 0. That's okay? Do me a favor, go take calculator. Tell me what I get for you. Huh? 4 plus or minus I, right? So 4 plus or minus I. So if you come back here, alpha will be 4 and beta will be 1. Okay? So I just writing that here for you to know. Alpha is 4 and beta is 1. So therefore, the complementary function is y is equal. All you have to do is write this back. That's all. You're just writing this back because you got complex roots. Y is equal to e to the alpha, which is 4x, open brackets, a cos beta is 1, right? Plus d sine x. Okay, that's what I write it. Right? Remember, alpha is 1, alpha is 4, beta is 1. Same thing, and sorry? Good talk. How about you, sorry. How about you, sorry there. Hello, okay, online? Amanda? Hello, okay? Right, take this and find the complementary function. Okay. Then last one. And last one. But change particular solution to particular integral. Make a mistake. A particular integral. Somewhere I had another complementary function, right? Change to particular integral. One of the particles has a particular solution, by the way. That makes it up. Right? So how we doing this here now? All we have to do is to write the auxiliary. Right? The auxiliary will be u squared plus 3u minus 10 is equal to 0. When you solve it, alpha is what? Normally alpha is the smaller value, right? Alpha is what? And beta is 2. It don't really make a difference. All that will happen is then your value just be a different, but you'll get the same equation in the end. So the complementary function now is y, right? We'll be using two solutions, right? We got two distinct solutions, so we're using this. Y is equal to e to the alpha, sorry, e to the minus 5x plus b e to the 2x. That's the complementary function for this. Okay, so when it's equal to 0, easy, right? The only problem is you have to remember 1, 3, right? Shibis, what are the three possible complementary functions? Right? Put two real roots for equal roots and for complex. Now we're going to change it to non-homogeneous, right? How we'll handle that. Right? So we're going to change it to non-homogeneous. Right? In exam, this is what you will see, right? Non-homogeneous. Right? So of course, if it's equal to this, as I said earlier, the solution is y is equal to, I'll call it general solution, right? And the reason I call it general solution is that you will see within your solution A and B, right? Here. Okay. So how general solution, right? I showed you how to get CF already, right? So we're gonna focus on how to get the particular integral. So to get the particular integral, we have to use something called a trial solution, right? And I'll show you how to get a trial solution. You can figure them out. And then after we do the trial solution, we're going to substitute that trial solution because we see we don't know what the actual answer is. So we're trying something to see if it will satisfy this. So I'm going to give you a trial possible solution for this that you'll add here, but we're going to have to try it and see if it actually works, right? So the trial solution, we're going to put it in here. And then when we put the equation in there, we are going to solve for the unknowns and then get a particular integral. And I'm making sense yet, but I'm going to show you. All right, ready? So I want to show you this. It's real simple, right? But it's become a little tricky sometimes when you have to solve two equations or solve three equations. But it's real simple. All right. So in order to solve this, we have to get two parts. We have to get the complementary part, which means taking this, make it equal to 0. Right, Manaya? Right? And then when you make this equal to 0, you solve it like normal, you get a complementary part. Right? The particular integral now, the particular integral is really based on getting these two steps here. So I will, by looking at this, we can figure out what a possible solution will look like. Okay? What I'm trying to say is that if I give you that solution and you double differentiate it and you minus it from the single differential and you add it to 5 of that value, you'll get it. Right? That's what the particular integral means. So the particular integral, let me make sure you understand. The particular integral is some y value that when you double differentiate, single differentiate, and put it back in there, it will give you this. That's okay? That's really what it is. So what you will be able to do, I'll give you a little table just now. You could look at what x is and figure out what the child solution will look like. You don't know the values, but you know what it will look like, right? Most times when it's linear, it's a linear child solution. If it's a constant, then they'll give you a constant. If it's a quadratic, then it'll be a quadratic. If it's a cos or a sine, it's a particular trig function I'll give you. I'll give you the table with all of them, right? So here, do my favor, find the complementary first. Do my favor and find the complementary function. Try that fast. Do my little favor and for this equation, find the complementary function. Right. right? Except for the last 2 years, they used to give it a trial solution. Now we had now we had a little right? All the earlier years, you will see question number say try this as a trial solution. But of late, they didn't want to know that. Right? Ready? So if y is equal, sorry, so if I take this and convert it into this auxiliary and I solve it, I got 1 plus and minus 2y, right? So alpha will be 1, beta will be 2. So you have, it will be alpha x here, so 1x, right? That's okay? Right, that's the complementary part, right? So that should be okay, right? Now to find the particular integral. Because we have a constant here, we can say that our trial solution for y, again, I will give you a table with all of these just now. The trial solution for y, we could call it cx plus d. It's normally mirror what you have here, right? So a trial solution for y is cx plus d. So our goal really and truly in finding the particular integral is to find c and d. That's okay? Our goal is really to find c and d. So what we have to do now is to put y in here. We already have y. We need y prime. Y prime is just differentiating this. And we need y double prime. That's okay? And now I am going to substitute an equation. Let's call this equation 1. And then I'm going to solve C and D. Are you okay with that? I'm going to substitute this, and this in here. So I'll get 0 minus 2 by C plus 5 by Cx plus D is equal to 10x plus 1. Multiply this out, and I will get 5Cx plus 5D minus 2C is 10x plus 1. Are you okay with that? All we have to do now, is compare, right? All we have to do now is compare. So if I compare, I'll see that 5C is 10, 5C is 10, so therefore C is 2. And then I'll see that 5D minus 2C is 1, right? So I can solve for D, right? D will be, C is 2, right? So that's 4, 5, 1. D is 1. That's it. So therefore, our particular integral is 2x plus 1. If I take 2x plus 1 and put it in here, I'll get that. That's okay? So therefore, I can squeeze it in here. Therefore, the general solution is y is equal to the complementary plus the particular integral. So it means y is equal to this, e to the x sorry, yeah. So this is complementary function, and I'm going to add it to the particular integral, which is this plus this is the general solution for this. That's it. That's okay? They can't really make the complementary function difficult. What they can do is they can make this a little more difficult. Right? Sometimes you will get quadratics here. That'll make this longer. Sometimes you could end up with functions with e, cos, and sine of things. Okay with that? So what they're doing is they're taking a trial solution, differentiate, double differentiate, plug it in, compare. They put that in there. Right? That's how you get the last part of the solution to get it. This part of the solution will help you solve. Right? When you finish, try numbers. And we have this topic. Take your time. Anybody confused? Stop. I can give you a child solution. Oh no, this one, just like ours. Y is CX plus U. Right, of course, use the trial solution. Y is CX plus D, right? It's linear, right? I'm gonna give you a table that's not. Can I finish already? So I can see on the equation. Yeah. Not running. Ready? We get C and D. Yes, which yes. Bring it up to huh? Here again, sure. They'll be like shit, like we'll deal with right. But we're only thing in the meantime, no boy. But how much you got? Double? Yeah, double for now. Aaron, book out something. One block past paper, so.
I think I put a question.
I thought it was you. For me again. Again. That's about people are mistaken. All of them like it. Good. Can I say so? What y'all got online? For those who finish, check in the group. I sent you a list of the trial solutions, right? That's a general form of it. I have a longer one, but I don't see it. I'll wait and send it. It wasn't there last. I remember giving it to them last year. Do you have any longer list? Right, so on the group there, I sent a trial solution list, add it in up. After this one, you can write the notes in the meantime, right? But I worked out now, right? Should be changing. Pick up your pen. Pick up your pen every time. What are you doing? Brainstorming. Did you see how much you got? Yeah. Yeah. And yes, 18. I'll check and see. Let's see what we got, right? So to get the complementary part, I am going to write the auxiliary equation. The auxiliary equation is u squared plus 6u plus 9 is 0. When you solve it, you got u to be what? One value? -3. U is -3. So therefore, the complementary function is e to the minus 3x a plus bx. Please remember the reason we have a and b here is because this is the general solution, right? If you had to get a particular solution, then you will substitute y and x and get a and b. Right? Remember, we cannot separate what's a particular solution and what's a general solution lastly, right? So a general solution is like this. It has a and b. Okay? But if I said when x is 4, y is 3, you can plug it in here and solve. Right? Of course, I'll have to give you two sets of values, right? Particular integral, because the f of x or the right-hand side is linear, we know that the trial solution, y is equal to cx plus d. All right? You have to figure out the trial solution. You have to learn that table that's sent today. All right? You have to learn that. So y prime is c, y double prime is 0. So I'm going to substitute in equation 1. Of course, this is my equation 1. So I'll get 0. I'll get 0 plus 6 by c plus 9 by cx plus d is equal to 9x plus 24. Right? I am going to compare both sides and I'll get minus 6c Huh? Plus, oh yeah, sorry, I get minus. Plus 6c is equal to 24. So I'm going to get c is equal to 4. Oh, wait. I jumped the gun there. Sorry. So I must work it out on those skip steps. 9c is equal to 9. So c is 1. Right? And then 6c plus 9d is 24. This is 1, come 18. I get 9 is 3. Sorry, what did I say? 9 is 3? Sorry, I meant I got D is 2. Sorry there. D is 2. Right? C is 1, 24 minus 18 and divide by 9. And divide by 6, sorry. So therefore, I'm just bringing it together here. Therefore, our general solution is y is equal to complementary function e to the minus 3x by a plus bx plus the particular integral, which is 1x plus 2. That's all they're doing. That's okay? Easy maths, right? And it's not taking you long either. That's yes. I'll give you a long one that's not. Any questions online? Any questions? Anthony? Okay. Arian, are they okay online there? No, I good. That's Arian. That's yeah, same for Arian. Next Arian, you okay? Raj, you okay? Eden Edessel? Huh? No, you sure? You sure you're there? Ashley. Nice day then. Ashley. You okay with us? Ashley not there. All right. So just take a little minute, look at the group. Look at the group. I don't want to write on that whole thing, right? So if the right hand side, you've seen it, right? If the right hand side is constant, then the trial solution is just alpha. Right? You can use alpha, you can use C and D of T. Right? If it's a polynomial, it will look like that on the right side. So for example, if it's x to the power 1, it will simply be, I'm going to show you what I mean, right? Just in case you don't understand now. If it's x to the power, let's say it's x squared. Let's say the right hand side is x squared. Your trial solution will look like this. You follow that? You're using their symbols. You'll get alpha x squared plus beta x plus some symbols. Come on, let's see. That's okay? That's all it's saying. If you have a quadratic, you'll get something like this. You okay with that? So that's a general formula that you can use, right? Or learn. Next, if you get exponent, is alpha e to the x. If you end up with something like this, though, if you end up with something like this, x e to the kx, you'll recognize that the form will change slightly. You will end up with something linear to represent this, and then something to represent e there. Right? So you're going to have to use product rule here. So that's where it becomes harder. Are you okay with that? So you're going to have to use product rule here to get y prime and y double prime and then you're substituting that back into the original thing. That's where it becomes, a little bit long. Are you okay with that? So the problem is it don't always simplify out so nice and easy. Sometimes the first differential is a product rule, and then you have to work out all them things. And that's all I'm giving you now. Right? Let me give you one. I'm gonna see. Okay, there is thing here. I don't like it. Okay, yeah. Am I right then? Ready? All right. Let's try June 20. I'll give them a trick. Let's try 24th. June 2013. I'm sorry. Huh? 22. Let's try 22. Right? If the trial solution is trigs, then sorry, if the right hand side is trigs, then it will look like this, right? So in 2014, they gave you this. Solve y double prime plus 2y prime plus 5y is equal to 4 sine 2t. Trial solution, of course. Trial solution is c cos 2t plus d sine 2t. Find for e, find your general solution. By the way, can you all look at what I sent on the group there and see this as a trial solution? Watch it good. That was the right hand side. You're seeing that? That was the right hand side, so that's a trial solution. That's okay? So you have to learn that table I gave you, right? Are you okay with that? This one a little more challenging because you have some comparing to do, right? Go ahead. Try this here. Very confused? By the way, you remember the differential. Sorry, what up? You remember the differential, right? Okay. Why is equal to C company? That's a bit hard with the differential. Yeah. All right, let's show this one. I will show you a way that might help you with the comparing coefficients, right? You don't have to do it if once you can pick out necessary things, right? So the auxiliary here will be u squared plus 2u is 0. So you got u is what? -1? Okay, nice. So you'll get y is equal to e to the -1x. Sorry, it shouldn't be x. The variable is t. So it should be -1t by a cos 2t because it's two t's, right? Plus b sine 2t. Right? So you have 2t here, so it kind of coincide in there, so we're good to go. Next, particular integral. Our trial solution, they gave us a trial solution of c cos 2t plus d sine 2t. So first differential, that'll be minus 2c sine 2t plus 2d cos 2t. Y double prime will be minus 4c cos 2t minus 4d sine 2t. Right. Problem is we had to put that in there and then simplify it out. That's okay? Right. So here's what I'll do sometimes. What you could do is this, right? Remember is y double prime plus 2y prime plus 5y. That's okay? Here's what you can do. If you do like this, nothing wrong with that, right? If you want, you could directly substitute everything in there. Okay? But I just want to show you something else that you can do so that you don't make mistakes with your lining up units and thing, right? So y double prime, I write in that first. Y double prime is minus 4c cos 2t, right? Minus 4d sine 2t. Please remember on the right hand side, there is no cos 2t because technically the coefficient is 0. That's okay, Emily? Right? So I wrote y double prime. Now I am going to write 2y prime, but I'm going to line up the cos 2t's with the cos 2t, right? This is y prime. So therefore 2y prime. So therefore 2y prime will be equal to 4d cos 2t minus 4c sine 2t. So I just line up all the cos, I line up all the sine. That's okay? 2y prime, that's the formula. Right? Now 5y, align the cos and the sine, right? 5y will be 5c cos 2t plus 5d sine 2t. You okay with that? And now I'm going to add everything. Add and add. Add. Right? So I'm going to get minus 4 plus 5, that's 1c, plus 4d, that is cos 2t, plus minus 4d plus 5d, that's 1d, minus 4c sine 2t. That's okay? Again, you don't have to do it like this. I just do it like this so that it's nice and easy to see everything. Right? And then we know that all of this equal to, upper in the cos first, right? 0 cos 2t plus 4 sine 2t. Are you okay with that? Right? So now I can compare. So I'll get c plus 4d is 0. And I will get d minus 4c is 4. Right? So I can easily find c. C is minus 4d. I can make c the subject here. C is minus 4d. Therefore, d minus 4 minus 4d is 4. So d plus 16d is 4. So I got d to be 4 and 7. Right? Yeah, that was the answer. D is 4 and 7. Right? And then find c. C will be minus 16 and 17. Anybody got this? Huh? Calma. But you'll follow what I did here? I just try to make it a little easier for you to find everything. Okay? You'll recognize when you make it substitution, it get a little confusing, it get a little jumbled up. So I just separate it out. Okay? So your general solution is y is equal to e to the minus t a cos 2t plus b sine 2t plus C and D, right? Plus minus 16 on 17 cos 2t plus where D 4 on 17. Right. Right, so here's where it becomes a little more challenging, right? Any questions there, William? You okay with that? One more. But remember, it's 4. The 2 1 week to the next week. Well, yeah, but technically without some of them because they are not under. The pure and best, pure and best. 2 hours. They're going to do all pure 1 4 hours. Now we have 200. That's 2 ways. Are you okay with that? Alright, I will kill all with one more, right? Now, but you all follow the process, right? So you find the complementary using the auxiliary to get it particular. You start with the trial, you differentiate, double differentiate, put it back into the equation, right? The hard part is just simplifying it. That's all. It is not difficult, but please remember how to differentiate. Next week we can do one where you have product rule and thing, right? Then we think it will be a little bit longer. Next week you might just do like few questions. I don't like. That's it there.